children, welcome to digital classes. Children, I hope you all are learning all the chapters. Children, in today's class, we are going to learn about a very important concept of physics, that is heat. What is heat, children? Do you know anything about heat? Did you learn anything about heat in your previous chapters or in your previous classes? So, let us see, children, what we have already learned in our previous classes about the well-known concept of heat. So, children, I hope you have some previous knowledge about the concept of heat and another associated important word, temperature. Right, children? This you have learned in your 7th class already. So, we had learned the words hot and cold are relative terms. Yes, children? They are relative terms. What do we mean by them, children? You already came across this word in the relative motion topic. In 2nd chapter, you came across the concept of relative motion. Relative words like up and down, left and right. These are what, children? These are relative words. Similarly, the terms hot and cold are also relative words. That is, we can say an object is hot only if we have an object which is colder than it. Okay? Suppose we have another object which is at a higher temperature, which is more hotter, then this object appears to be cold and the second object becomes hot. So, children, in this manner, the words hot and cold are relative terms. Then, we have come to know that heat is a form of energy. It makes an object to appear hot or cold. So, children, heat is that form of energy which makes us feel whether an object is hot or cold. Then, we also saw that it flows from hot bodies to cold bodies. So, children, in general, we can say that heat is a energy which can flow from hot bodies to cold bodies. If you have seen in your house any time your mother trying to give you a glass of hot milk, but if it is very hot, what do? Yes, we try to keep it in a cold water bath. Take a big bowl with water, keep the hot glass of milk in that. What happens after some time? You will observe that the water in the water bath is becoming hotter and the glass of milk, the milk is getting colder. So, what is happening here, children? The heat from the glass of milk is getting transferred to the water in the water bath. Right, children? So, that is how we are saying that heat flows from hot bodies to cold bodies. The terms temperature and heat are used to describe the hotness or coldness of a body. So, we use these two terms, heat and temperature, to measure or to understand the hotness or coldness of a body. Children, in our class, we will also understand how these two terms are different. Temperature is a measure of the degree of hotness or coldness of an object. So, this is also you have learnt in your 7th class, children. What is temperature? You also listen to news or see in the newspaper every day. The day-to-day temperatures are recorded. Right, children? Now, suppose it is the month of April or May. Soaring high temperatures. The news reports soaring high temperatures of 40 to 42 degrees centigrade, right? And suppose it is winter, say the month of December or January, the temperature may fall to as low as 15 to 20 degrees centigrade. Isn't it, children? Not only this, when we are suffering from fever, usually we check our body temperature, right, children? So, the normal human body temperature, 98.4 degree Fahrenheit. Yes, children? So, we are getting the measurement of temperature. We are measuring the hotness or coldness of a body or an area with the help of temperature. So, children, these are the previous knowledge that you might have got in your 7th class. Now, let us see what we will be learning in our today's session. In our today's session, we shall learn about transfer of heat. How heat is transferred. Does heat really get transferred from one place to another place? Thermal equilibrium. We are going to learn about a new term called as the thermal equilibrium. Difference between heat and temperature. Then we are going to learn about the units of heat and temperature. Yes, children, these are physical quantities, so they should be having some units. Then we will see the relation between temperature and kinetic energy. What kinetic energy are we talking about? Yes, the kinetic energy of the particles or molecules. Then we will see that temperature denotes the direction of heat through an activity. Okay, children? So let us begin with transfer of heat. Children, let us consider a wooden block and a metal block. So we have two blocks here. One is a wooden block and another is a metal block. Both of them are of the same dimensions, children, that is the same shape and size. Okay. Now, what do we do with these two? Let us take these two, keep the two blocks in the refrigerator for some time. So, let us open the door of the refrigerator, children. Yes, let us assume this is our refrigerator and here goes the wooden block first and then the metal block. Let us keep them inside for some time and remove them after some time and touch. Take wooden block in one hand and metal block in another hand. What do you notice, children? What do you feel when you touch these two? Yes, they appear to be cold, don't they? Not just wooden block and metal block, children. Any object that you keep in the refrigerator for some time appears to get cold, right? So let us understand why is this happening. So what do you observe? We observe that both the blocks become cold. The blocks became cold because they lost their heat energy when kept in the refrigerator. So children, inside the fridge, the temperature is low, whereas the wooden block and the metal block were warmer compared to the refrigerator. Okay. So when you kept them inside the refrigerator, they lost their heat energy to the refrigerator. Okay, children? That is why when you remove them outside, they appear to be colder. Now, which block became more cold? So when you touch them, children, even without doing them directly, it is our common sense, children, which tells us which block will get colder. You can as well try it, children. We know that the metal block gets colder compared to the wooden block, isn't it, children? The blocks lost their heat energy when kept in the refrigerator and the metal block appears to be colder than the wooden block. But children, did you notice that both the wooden block and the metal block are of the same shape and size? And they were also kept in the same refrigerator for the same period of time. Then why is it that the metal block is getting more colder compared to the wooden block? What is the difference here in between these two blocks? And how is it that we feel that the metal block is more cold than the wooden block? The reason here, when we touch the metal or the wooden block, the heat is transferred from our fingers to the blocks. So when we are touching the blocks, the heat from our hands is moving towards the blocks. Why, children? Because our body is at a warmer temperature. Our body is warmer compared to the two blocks which are taken out from the refrigerator. So when heat flows out of our body, we get the feeling of coldness. So we are giving out cold heat, children. Our body is losing heat to the metal object or the wooden object. So when we are giving out heat, definitely we will get the experience of being cold. Okay, children? Let us see this. See this arrow mark, children. This is the metal block and the bigger arrow mark indicates more amount of heat is flowing from our hands to the metal block. And here, this is the wooden block. A smaller arrow indicating lesser heat being flowed to the wooden block. Okay, children? Which means the metal block is receiving more heat from our hands. That is why we feel more colder. We feel iron block or metal block is more cold. And the wooden block is taking less heat from our hand. So it appears to be less colder compared to the metal block. So this is how transfer of heat is taking place, children. The metal block appears to be colder because more heat energy flows out of our body when we touch metal block. As we saw in the animation, children, when we touch the metal block, it is receiving more heat energy compared to the wooden block. Okay, that is why we feel that the metal block is cold than the wooden block. degree of coldness of metal block is greater than that of the wooden block. The degree of hotness or coldness of a body is measured as its temperature. This is the definition of temperature, children. It is called as the conventional definition of temperature. That means the regular definition of temperature, the degree of the measurement of the hotness or coldness of an object or a body or an area is called its temperature. Now children, we will try to understand another important concept called as the thermal equilibrium. For this, let us take a hot body and also a cold body. So children, here to understand thermal equilibrium, we have a hot body denoted by red color symbolically and a cold body denoted by a blue colored object. Okay children. Now what are we going to do with these? We are going to bring these two together. We are going to bring these two together, the hot body and the cold body. What will happen children when we bring these two together? Yes, heat is flowing from the hot body to the cold body. You can see the black arrow marks children. The black arrow marks here, they indicate the direction of the heat flow. Heat is flowing from the hot body to the cold body. Right children? So this you have seen in the example that I have given. Taking a hot glass of milk, keeping it in cold water bath. After some time, what will happen children? The water is getting hotter and the milk is getting colder. Now till when will this happen? Till when will this transfer of heat take place? This transfer of heat will take place till both the bodies come to a common temperature. So here children, now after the flow of heat is completed, how is it completed children? Now both the bodies are at a common temperature. The hot body continuously gave off heat to the cold body. So the hot body lost some amount of heat, the cold body gained some amount of heat. Okay, so it is decrease in heat, increase in heat. At a certain point, both of them came to a common temperature children. This is called the attainment of thermal equilibrium between the two bodies. Okay children, now these two bodies are in thermal equilibrium with each other. So a state of body where it neither gives nor receives heat energy is called thermal equilibrium. Now these two bodies, this is not giving heat, this is not receiving heat. Okay children, so both of them have come to a constant temperature now. So no more heat flow takes place. Okay, when the bodies attain thermal equilibrium, no more heat flow takes place. A state of body where it neither gives nor receives heat energy is called the thermal equilibrium. Children, now let us see a small video.
Let us take a laboratory thermometer. Observe the reading on this thermometer. It is approximately 30 degrees Celsius. Now let's take a beaker of hot water and place the thermometer in the beaker. Wait for few minutes. After few minutes, we observe that the temperature in the thermometer has risen. It now shows 70 degrees. Now take a beaker of cold water and replace the thermometer and observe the readings. After a while, we observe that the temperature of the cold water is nearly 25 degrees Celsius.
So when kept in hot water, the heat is transferred from the hot water to mercury. So why did the mercury level rise children in hot water? Because heat was transferred from water to mercury. When the thermometer was kept in cold water, then heat was transferred from the mercury in the thermometer to the water. Okay children, in this way we can understand the transfer of heat from hot bodies to cold bodies. Okay children, so let us see the conclusion of this activity. Heat is a form of energy in transit. Heat is a form of energy. We always know this children. In transit means which moves continuously, which is in transmission continuously. Okay, children? So heat is a form of energy in transit that flows from a body at higher temperature to a body at lower temperature. Is it okay, children? So heat is an energy which is continuously moving from a body at higher energy level, higher temperatures, to body at lower temperature. This can also be understood as heat flows from higher temperature regions of the earth to the lower temperature regions of the earth. That means heat is flowing from the equatorial regions to the polar regions, children. Okay, children? Heat can flow from the equatorial region to the polar region. This is the reason for the convectional winds that we have learned in our social studies also. Right, children? Now, thermal equilibrium is attained between water and mercury. Now, we have seen that when you keep water and mercury and leave both of them for some time, then they both will come to a stable temperature. Yes, children? They both will come to a stable temperature. So that is what is the temperature of water or the room temperature. So temperature is a measure of thermal equilibrium. This is another definition of temperature, children. Temperature, when we are talking about more than one system, two or more systems, then the temperature is measured as temperature will be a measure of thermal equilibrium. I hope it is clear to you, children. Let us see a law here of thermodynamics, children. Thermodynamics is nothing but the study of heat. Okay, it is a branch of physics which is studying heat. So there are three laws in thermodynamics, children. So we just have a small introduction for the 0th law. We have three bodies, A, B and C. They are such that the body A and body C are in thermal equilibrium with each other. You can see here, children. This means that they both are in thermal equilibrium. And B and C are also in thermal equilibrium with each other. Same denotation here also, children. Then, according to this 0th law of thermodynamics, A and B are also in thermal equilibrium with each other. If two bodies, A and B, are in thermal equilibrium with another body C individually, then the two bodies A and B are also in thermal equilibrium with each other. This is called as the 0th law of thermodynamics, children. Now, children, let us move on to learn the units of heat. As I told you, heat and temperature are also physical quantities. Heat is a form of energy, children. Yes, it is very much energy. So it should have units. And temperature is a measurement, children, isn't it? Temperature is a measurement, just like our distance, mass, time. Temperature is also a measurement. So it should also have some units. Okay. So first let us see the units of heat. As I told you, children, heat is a form of energy. So therefore, the units of heat should also be the units of energy, which is joule. Yes. So the SI units of heat is joule, which is named after the famous scientist James Prescott Joule. So he is the scientist, children, James Prescott Joule. The word joule or the unit joule for energy is given after him. The CGS unit for heat is calorie. Did you hear this word calorie, children? These days we are hearing them a lot. Like people, when they are consuming food, they are counting the calories. How much of energy does this food contain? Yes, children, they are scared to consume more caloric food. High caloric food should not be taken. Why, children? Because you have to burn it also. You have to burn the high calories also. So people usually avoid taking high calorie food because it may turn into fat. CGS unit is calorie. The definition of calorie, children, the amount of heat required to raise temperature of water by 1 degree centigrade is called a calorie. So the definition of calorie, children, the amount of heat required to raise temperature of water. Suppose we have some amount of water. So in order to raise the temperature of water by 1 degree centigrade, how much amount of heat do we require? That amount of heat is called as 1 calorie. Now there is a small conversion factor between the calorie and the joule, which is given as 1 calorie is equal to 4.186 joules. Okay children, 1 calorie is equal to 4.186 joules. This is an important conversion factor children, or we can usually round up to 4.2 joules also. Now let us see the units of temperature. We have different units of temperature children. The SI unit of temperature is Kelvin. Okay children. So this is named after Lord Kelvin, and another unit is degree centigrade or degree Celsius. This is also SI unit only children. This is named after Anders Celsius. This is named after Anders Celsius. We have a conversion here children from Celsius to Kelvin. 0 degree centigrade or 0 degree Celsius is equal to 273 Kelvin, such that if you want to calculate temperature in Kelvin scale, then we have to add 273 to temperature in Celsius. That is, let K be the temperature in Kelvin and T be the temperature in Celsius. Then K is equal to 273 plus T. And the temperature measured on Kelvin scale is called as the absolute temperature. Okay children, if we are measuring temperature on the Kelvin scale using the Kelvin scale, then it is called as the absolute temperature. Let us do a small problem children, converting Celsius to Kelvin. Convert 100 degrees Celsius to Kelvin scale. So we have been given that T is equal to 100 degrees centigrade, and we know K is equal to 273 plus T. So what do we do here children? Yes, just add 100 here. Just add 100 to 273. So K is equal to 273 plus 100, which gives K is equal to 373, or 100 degrees centigrade, 100 degrees Celsius is equal to 373 Kelvin. Now let us look at another small problem children in the reverse way, Kelvin to Celsius. We will calculate here Kelvin to Celsius. Convert 300 Kelvin to degree Celsius. So given here K is equal to 300 Kelvin, we know K is equal to 273 plus T, such that T will be equal to K minus 273, which is given by 300 minus 273 is equal to 27. So T is equal to 27 degrees centigrade or 27 degree Celsius. Simple children, isn't it? So you can expect these type of questions in your exam. Now children, here we are to understand another important phenomena about the heat and temperature of a body. Right children? So we know children that the particles of a substance are in motion. Isn't it children? Especially if you talk about liquids and gases. The particles or the molecules inside them are in random motion. So what type of energy do they possess children? Yes, kinetic energy. Energy by virtue of its motion. Okay. So here children, just look at the movement of the particle in the hot body, and at the same time look at the movement of the body in particle in cold body. Yes children, do you find the difference? How is the particle moving in the hot body? Very fastly, whereas the particle in the cold body is moving very slowly. Isn't it children? So the average kinetic energy of the molecules is directly proportional to its absolute temperature. Absolute temperature is temperature measured on Kelvin scale. Okay children, we are going to understand another small activity. For this, we need to take some hot water in a container. Slowly pour some coconut oil on the water. The water is approximately 60 degrees centigrade children. So slowly pour the coconut oil on that. Now take a lid and put 2 holes. Make 2 holes on the lid. Keep it on the container. Now insert 2 thermometers through these holes such that the bulb of one thermometer lies inside water and the bulb of another thermometer lies in the oil. Now children, make note of the readings. How are the readings changing? What did we observe in the activity? We observed that the temperature of oil is increasing and that of water is decreasing. The average kinetic energy of the particles of oil is increasing. In water, it decreases. So, in oil, the kinetic energy, the average kinetic energy is increasing. At the same time, in water, it is decreasing, children. Right? Why is it happening? The energy lost by water is equal to the energy gained by the oil. So, here also, heat is flowing from water to oil. We have taken water at higher temperature and oil at a lower temperature. So, heat started flowing from water to oil. So, the energy lost by water will be is equal to the energy gained by oil. The temperature determines the direction of flow of heat. Right, children? So, this is one of the important points that we have to learn today. How is the temperature changing, children? It is changing according to the flow of heat. So, first, when water was hot, it was high here, and the oil was cold, so temperature was low. The heat started flowing from water to oil, and hence the temperature is rising up from water to oil. Isn't it, children? So, temperature determines the direction of flow of heat. Children, we have come to the end of this session. Let us see what we have learned in today's class. We have learned that heat is a flow of energy. Temperature is the measure of hotness or coldness of a body. The state of a body where it neither receives nor gives heat energy is called thermal equilibrium. Temperature is a measure of thermal equilibrium. The unit of heat energy is joules. SI unit is joule. CGS unit is calorie, and 1 calorie is equal to 4.186 joules. Temperature is measured either in Kelvin or in degree Celsius. K is equal to 273 plus T. This is the conversion, children, from Celsius to Kelvin. The average kinetic energy of the molecules is directly proportional to its absolute temperature. So, these are the important points that we have learnt in this chapter, in this class today, children. So, try to answer the questions here. Differentiate between heat and temperature. From the lesson, now you can make points and write the difference between heat and temperature. Define thermal equilibrium. Convert the following into Kelvin scale. I have given two children here, 47 degrees Celsius and 127 degrees Celsius. Convert these two into Kelvin scale. Convert the following into Celsius scale. Now, two temperatures given in Kelvin scale, 273 Kelvin and 100 Kelvin. Convert them into degrees Celsius and explain an activity to understand the relation between temperature and kinetic energy. Children, try to answer these simple questions. I hope you all have understood today's lesson very well. So, meet you in the next lesson. Happy learning, children. Try to complete the worksheets provided by the SCRT also. Bye, children.